Good morning. My name is Jim Doleski. I'm with Teleglobe. We worked on some stuff with Alain Popescu from Renesys, Tom Skoll from SBC, and Todd Underwood also from Renesys about BGP filtering, the myths, legends, and reality, what can really be done, and what do a lot of folks believe can or can't be done. We're wondering, why do we want to filter? These are some of the things we're going to look at. Why want to filter in the first place? Why not just leave it open for everybody? Why not just use the IRRs, which a lot of people have used in the past or continue to use for some customer-based filtering? We're going to look at some techniques that we came up with and are looking at doing some further study on ways that we can actually do filtering as opposed to using the IRR data. What the router performances are going to be like by using these prefix lists to create fairly large sets of filters for your BGP neighbors, and then we'll sum up with what we've actually found as a result of all of this. So why do we want to filter peers in the first place? We've seen multiple occurrences over the last number of years of not just customers but actually peers not doing the right thing anymore and sending me routes that they shouldn't be sending me. We've seen cases of all sorts of route leaks. We've seen AT&T/8 being originated in Bolivia. We see /8s being originated out of China and Latvia, which are fairly safe to assume that there's not that much IP space in Latvia being originated from one provider. We see route hijackings. We see hijackings used for malicious activities, from spamming to black holing of legitimate traffic that should be destined towards our customers. So we see all kinds of long-term issues here that need to be addressed with regards to the level of trust we can associate with the routes our peers are sending us. So why don't we just all filter our peers? I truly believe that I can't think of anybody offhand that actually filters their peer routes coming in. Most of us filter our customers, or should at least be filtering our customers, but I can't think of any large providers that are currently filtering all their peer routes that they're getting from their peers. So what are the reasons that why nobody's doing this when I think most people believe it's probably not a bad idea? So the biggest single reason I think is that there's no good source of data that's 100% accurate. And 100% accurate is maybe a lofty goal to reach, but I don't think there's actually a source of data that's very close even to being maybe even 80 or 90% accurate right now. We don't have the exact number or rate of accuracy, but what we'll see in one of the slides coming up is that in some cases it's very far off the IRR data. So we're also going to look at a very frequently used argument is that this makes for huge router configurations, which it does. And there's also a belief that this actually will impact my router. And if I put on a very large prefix list, I'm going to have operational issues with the router actually doing its job of switching packets. So we're going to sum it up with looking at the cost benefit of this. Is it worth some degree of pain, once we define what that pain is, for the benefit of having a more trusted route set? So with regards to the accuracy of lists, and we're not bashing the IRRs here. We think the IRRs would be the perfect source of data if we had an accurate set of data in there to use. Because they were designed for this. This is the place that we're all supposed to go, put our routes, or have our customers put their routes so that we know what we can trust and what should be coming from where. A lot of us maintain these types of lists and prefix lists now for doing customer filtering, so we've already got some degree of mechanism in place that we can build these prefix lists off of if we've got the source of data to use. So this data doesn't exist now. Some registries are better than others that we've seen, but again, we're not there, and until we get there, people aren't going to use it as much as they should be. So we're hoping that by developing a technique that can successfully prefix filter large peers for their route announcements, it will actually encourage more people to use the IRRs to make sure that their data is up to date and accurate, so that it simplifies the whole process, and Todd will get into the process later on and you'll see why that's important. So we took one AS that we had some degree of suspect to with regards to their level of number of routes they're registering in the IRRs. And we took a look at 3 route registries, and we purposely blocked out the AS here so that we're not trying to bash anybody. So we looked at AP, NIC, Savis, and Vario, and the number of routes that are registered in the IRRs here, and the time that they actually started. So this AS was starting to register routes long ago, but we see now that of all the routes, at the most, 52% of the routes that we're seeing on the internet are actually registered in an IRR somewhere, which is a very, very low amount when you're looking to build something that would accept prefix filters or not. If I built my prefix filters off this, then I would basically be ignoring half of their traffic. I wouldn't be able to get to any of those routes. The total number of routes we're talking about here is 538 routes that are being announced across 6 different sessions that we looked at. So would basically be black holing around 250 routes, maybe a little bit more. So what we're going to get into in the next part of the presentation is we're going to attempt to debunk some of the myths about being able to peer filter with regards to there's no data out there. We just saw on the last slide that at best 52% in some cases of routes are being registered in the IRRs. The other myth we're going to attempt to address and partially debunk is the fact that the routers can't handle this load of applying very, very large access lists or prefix lists. We'll then go on to identify the set of techniques that we've evaluated for being able to generate the data source for these these prefix lists and apply them to the routers. We'll then get into the actual testing that we performed by applying the prefix lists on the router, see what worked, see what didn't, and see what kind of impact it had. And as part of that, we'll identify some of the deficiencies or weaknesses in the current generation of equipment that most of us are using across the internet. So now I'd like to get Todd to come up and discuss the approach that we used.
Cool tag team presenting. This is awesome. So we're moving fairly quickly here, but if people are interested, we're happy to talk about it afterwards. We just know we're behind schedule and we're trying to make up time in flight. So again, just to emphasize, we are pro IRR. We are not saying that in the long run these techniques are a complete replacement for the IRRs. What we're hoping to do, as Jim said, is come up with some techniques for supplementing the incompleteness of the IRRs and driving more acceptance of them. So we're going to start with, so I'm going to go over a couple very general techniques for how this can be done in terms of supplementing IRRs and coming up with relatively accurate prefix filter lists for large peers. This is an area of active research right now, and if it's a subject that people are interested in, please let me know, because there are a number of researchers who have some interesting stuff that we can get to present at future NANOGs. So you start with 3 things. 1 or more, hopefully more, somewhat trusted IRRs. But you're going to have to assume that they're incomplete because the numbers are just there. They're incomplete. And you're going to have to assume that there's some stale data in there as well. So you can't just blindly trust anything that's in any IRR at this point. But it's pretty good. It's a pretty good start. Start with a history of peer routes from some target peer. So this should already make you suspect about how we're going to deploy this on a router, and that's also a subject for future discussions. But it's going to be very important to trend the announcements as received from a large peer over some amount of time. And you will also need a route view style or RIPE-RIS style global peer set that will help you disambiguate truly novel announcements, and I'll go over that in a second. So here's the general principle. You've got a new announcement. The general background principle is that routes that are seen stably over a significant period of time and not yanked down are probably okay. Now that's a pretty weak assumption, and it's certainly up for debate, and the people who work at long-term AS hijacking and prefix hijacking, where we're not talking about just injecting a more specific, we're talking about walking off with address space that's not yours, those are not going to be caught by this. Our goals here are pretty modest. Right now, nobody's filtering anything and all the crap gets through. And we're just hoping to sort of turn down the volume of crap at least somewhat. It's a modest goal. An additional observation here is that delaying acceptance of truly new originations may be better than accepting all illicit paths. So this is an operator decision to make, but there's a question about how quickly somebody expects a truly novel origination to actually work. If they expect all novel originations of new big prefixes to just work within 5 minutes, then some of these techniques are going to be very bad for that. If most people start announcing things days or weeks or months before they put production services on them, then this won't impact them at all. And that's a subject that we're interested in feedback on. Certainly it's an operator decision. We're going to add 4 non-orthogonal dimensions because they do interact with each other. Again, registry information, we're going to look at origination, we're going to look at AS paths, and then we're going to look at the degree of peer confirmation across a large set of peers. So how do you validate a new announcement? Look at origin. You can reject things for origin. If the origination pattern, so the AS that's originating this prefix, is new for this peer and can't be confirmed either with an IRR or across a set of other peers across time, reject it for a little while. It's suspect. You have no reason to believe this is a non-registered route. The IP space is not allocated to the same organization that owns this AS. Nobody else has seen it before. Put it on hold. Look at it again tomorrow. Look at it again in 4 hours, depending on your settings. Invalid path. If the origination is okay, but there's something suspect in the path, and this is probably the most subtle and the most difficult aspect of this. Some route hijackings that we have seen, and a lot of leaking, involves very, very suspect paths. These are either synthetic AS paths that are just implausible or flat out impossible, or the leaks are sort of bouncing twice through large ASs as transiting a core, transiting an edge of the internet between the core and the core. So looking at paths, if there are unconfirmed adjacencies or the directionality can't be confirmed, reject it for a little while. Poor peer confirmation. If you have no reason to suspect something is valid until now, and you can't confirm it across a large set of peers, it's not stably routed. A lot of people don't believe it. There's no reason you should go with the outliers who do believe it. Reject it for a little while. The default here, accept. And this is important right now. As I said, it's much more important to find some techniques that filter out the egregiously bad stuff. And we'll look at getting the sophisticated cases next. So we looked at some results. We took peer routes sent to a large European-based network for the following ASs, and you can see the ASs there. If you can't read them, the slides are somewhere. And we took those trended over about 2 weeks. We wanted to see things like rate of change, what is the number of novel originations that you would see from a peer on a day-to-day basis, and how many of those are really hard to categorize. We're trying to get some scope to the problem. Is there a huge change per day, and are these all really tricky cases, or are the vast majority of these just slam dunk easy things? So we trusted the first table. We just waved our hands and said, on day 0, it's probably all fine. I mean, that's a silly assumption, but for purposes of a talk at NANOG, it's probably good enough. We looked at the daily novel route rate. It's a median of 0.5% with a max range of 3%. So you just don't, people don't change the number and the prefixes that they announce that much on a day-to-day basis. Fewer than, just using some very naive techniques that we looked at, that Aline and I looked at, very, very few routes are difficult to categorize. The vast majority of these are very easy. It's an origination seen from the peer before. It's an origination seen by lots of other peers. It's a path that's confirmable, accept it. So there's only 12% of these very, very tiny number of changes that are difficult to categorize. So our tentative conclusion, and this is all very early work, is that very, very naive techniques work well for normal peering sessions. We need to do a lot more research on what happens when somebody re-advertises a full table, or what happens when you really have a determined bad customer of a peer who doesn't filter their customers properly and they're doing sophisticated stuff. That's all subject for future work. So here's some specific examples just so people can get a handle on things. An easy one, here's a prefix, here's a path. This path, the whole path, was seen for a different prefix from that peer the previous day, and the origination of that prefix by that peer is confirmed in your global routes from a large number of peers over a long amount of time. So you believe it's a plausible origination, you believe the whole path, accept it, it's fine. A little bit harder, here's an example of a /16 that's originated both by 11351 and 701. So there's a lot of sort of thrown together multi-homing where my provider, I have an AS, but my provider still announces my prefixes stuff, a lot more than there probably should be. That's harder. It costs us to think a little bit about what stable origination might mean, and maybe how we want to allow stable multiple originations patterns. So if a prefix is stably multiply originated, maybe that's okay. Harder. Here's an example of a /22 that we saw that has a path that we can't confirm, and the origination is confirmed, but the entire path is tough to confirm. There's examples. This is exactly the kind of stuff that would be the most sophisticated and the most interesting. And it's the part that requires the most future work. You can look at sort of multiple AS, trying to match the longest set of edges and trying to confirm the directionality of overlapping pieces of edges such that you believe that, you know, in this case you have to believe that 35362 is a customer of 35409 and so on, and you have to believe that the whole path makes sense and that there really are these, you know, 5 downstream ASs on the other side of 702 from you in this case. It's not impossible at all, and there's big chunks of that we did confirm, but in particular the edge between the 35362 and 35409 was not something we could confirm, and it would be difficult for us in the current naive techniques to figure out how to accept that. Really hard. There was a talk a few nanogs ago about connections by Boeing. People feel strongly about how they do things, ranging from super cool to, oh my god, I can't believe they do that. But the fact of the matter is they do that, and if you want to route your traffic to people on planes on connection by Boeing, our system needs to be able to handle that. And that stuff is really hard because you have the same /24s routinely bouncing among ASs as planes cross the Atlantic and Pacific. And I don't have a good answer for other than special casing Boeing. Our current techniques don't scale to that particular interesting routing set of choices. That's the polite way to say that. So would novel announcements with these naive techniques have prevented some of the catastrophes that we've seen recently? The Turk Telecom 9121 leak, all that stuff would have been rejected for origination. You know, you're not going to, as a large peer of them or another peer, you're not going to believe that, you know, chunks of the U.S. federal government, Amazon, and Google just moved to Turkey. You just reject it for a little while, and it would have been cleaned up, and networks that ran anything like this would have maintained correct and sane routing tables, much more so than those even with relatively tight max prefix settings would have. The recent originations of 12/8 rejected for origination. Most hijackings rejected for origination. Even more specifics, and there's a couple of subtle points about more specifics that I'm not going to go into here, but I'd be happy to talk to people about afterwards. But so there's a trend here. Up till the last bullet point, origination is the way that you're going to catch the majority of the bad stuff. The hijackings with sophisticated forged AS paths, that's the tricky stuff, and that requires a lot more thinking and a lot more work at this point. As I say, this stuff is in proof of concept stage. It is difficult, but there are some interesting results so far, and it's going to require further work. The general idea of accepting novel originations being delayed, our idea with this is that, you know, as Jim said, there's a chicken and egg problem with the IRRs. If people don't build filters with them, no one has the incentive to update them. What we're offering here is a set of techniques where you can build filters bootstrapping the IRRs and drive acceptance of them, because the fastest way to get your routes accepted by people using techniques like these is to register them with an IRR that's trusted by that provider or the largest number of providers. These techniques are almost certainly easier, cheaper than SBGP, SOBGP, but they solve a different set and a much more limited set of problems. They're much less ambitious. So for people who are, you know, true crypto route signing believers who think that that's the right way to go and it's going to happen, you'll be very unexcited by these sort of half-assed, sort of hackish techniques. For people who are looking for modest practical solutions that may be plausible much sooner than SBGP, SOBGP, you may be interested in these techniques. Very important for us to pound our fist a little bit. There have been some recent surveys that suggest that 20 to 40% of even very large transit ASs don't currently filter their customer sessions. Please just do that first. Ignore the rest of this talk and the first part of this talk and just go filter your customers, because that'll make everything better for everyone for now. And then when you're done with that, you'll have an infrastructure in place for deploying filter lists, and you'll have an infrastructure in place for validating filter lists. So please go do that first. So I'm going to introduce Tom, and he's going to talk about what large prefix filter lists do to your routers.
Hello. So pretty much I kind of focused on the testing part and, seeing if the hardware can actually handle this. And one thing was we were going to be filtering prefixes per individual pair. So you had separate prefixes for every pair. We kind of looked at ASPath filtering earlier on, but, there's the issue with, different vendors have different ways that they interpret ASPath filters. We kind of looked at maybe doing like a one true list and, but we kind of just decided to go back to just a regular prefix list. So to simulate this, several ASNs were shown previously in the presentation. So there was about 9 of them. So we had 9 eBGP multi-hop sessions. We did not enable MD5 on them, and that was just because the route generator couldn't support it. And MD5 has its own effects with BGP, but that's a different talk for a different time. And so there's 3 different tests that we really ran there. We ran, each test was about 20 minutes long, and we did a test where, we established the sessions. 5 minutes into it, we brought up the actual BGP sessions. Another one where we had the sessions just come up, stay established, and let it run, see if anything weird happened. Another one, 5 minutes into it, we tore down the sessions to see what would happen. So here's the prefix count per neighbors, and, they're fairly realistic, so a good amount there. So there's 3 different vendors that we actually tested here, on the Cisco platform, the Alcatel 7750 and a Juniper on a RE4. And for the Cisco side of things, here's just like a before and after of what the actual prefixes did to the configuration, how much memory, how much NVRAM was occupied by the actual configuration. Load up time was, decent, and what the final end configuration size is, listed there. So this didn't work on some platforms, mainly because of the NVRAM limitation. So gRPB, it would not work. Catalyst 6500, a SOUP2 MC2 is not going to do this. But the SOUP 720, PRP1s, PRP2s, it loaded out on okay. So here's some graphs, just pretty much monitoring CPU utilization as we brought up the BGP sessions. And there's really not that much of a big difference. You have, before and after, and they look very similar. So I'm not going to spend too much time on them, but they're pretty easy, and you can, look at the presentation and take a look. Here's it with the PRP2. Not that big of a difference, really. So. We also tried this on the Alcatel. It took a little bit longer time to actually commit the actual configuration into the running configuration. And once again, not that much of a difference with prefix filters and without. And we just recently got access to a Juniper RE4 thanks to Juniper earlier yesterday. And we really didn't see much of a difference, not really an impact at all. So it's kind of interesting. So there's some kind of conclusions that we realized with the actually testing this, and that is the prefix filters, other than they really don't seem to have any impact, and there's really not that much of a downside of actually applying it to pairs. The other issue is really the way of how you put on prefixes onto a router, right? Typically router configurations are one big flat text file, right? So, someone does show configure, show run, they got to wait for the whole thing to spit up, and, a lot of people don't like that, and it's not that great, but, it does work. But, maybe vendors could possibly look at changing things around to, having a prefix list be a separate file on the file system. So number one, it doesn't go into NVRAM, and you just have to call it, and that way when somebody wants to do show run or show config, they don't have to sift through the whole prefix list. So that might be an idea there. And for conclusions, one of the things is we need to drive people to adopt the IRs. I mean, it'd be great if everyone did. It's pretty simple. So it is possible to validate pair routes as advertised, as they've shown there with Todd, that there is analysis that you can do to determine what is good, what's suspicious, and whatnot. It is possible to actually manage these large prefixes on routers. It's doable. It isn't that great, but it will work, and that's probably no excuse not to do it. But large operators who are filtering should possibly consider these techniques. I mean, they could probably work with the vendors if they have issues with performance and things like that, but it's worth a shot. So that's it.
We have time for a couple questions. Well, maybe we'll start with the question from the middle, because the mics in the middle probably work.
Scott Lybrand, Internet. One thing I'm missing here is how do the new unknown advertisements get evaluated by the routers? You have these static prefix lists on the routers for stuff that's already there. When something new comes in, how do you even do the evaluation?
Yeah, so as with, it's a great question. I think it's I have some suggestions, but it's a little bit up in the air. One of the ideas is people are going to redeploy filter lists on some finite clock scale, and it's not going to be every second. So the real idea is poll the routers for received routes that were not accepted, evaluate those, build a new filter list, and redeploy it. So as with all filter lists, the stuff that you're advertised that's not accepted is rejected until you build the new list. Is that?
So in that case, then your default accept is no longer true in an immediate time scale, but it is true over a longer time scale.
I'm sorry, that's absolutely correct. Yes, the default accept. I mean, in fact, you could do a default accept on the list, but then you would want to really have a much tighter time scale for redeploying new filter lists. But yeah, that's absolutely correct.
Just to follow up, how do you poll the router for things that aren't accepted?
So you can do, there's a variety of ways that are router dependent, but you can show received routes and look at the ones that were rejected. So now it's Jared.
Yeah, Jared.
Sorry. Jared Mochverio wanted to ask if SBC is registering all their routes. I also wanted to comment on the Vario thing. Could you send me a list of the ones that we seem to be missing so we can correct that? That is likely just some sort of an oversight on our side, and we would be happy to work on correcting that. Additionally, on the new prefix side thing, something that I had talked about in a slightly different form with some people was about essentially having a longer time scale for dampening, where you would not accept some sort of a new prefix for a period of time, and it would gradually, increase in either local pref or something else. And people who are thinking about this might want to talk to your vendors or talk about that type of a thing and how they would manage these large configurations and such as well.
That's actually the simplest version of this idea that looks like it works really well. And there's a guy at University of New Mexico who's done recently published a paper about that I'm going to try to get to talk at the next NANOG or following. But yeah, I think that's one of the core ideas is that if operators are willing to delay for moderately long periods of time genuinely new prefixes, it looks like an enormous number of problems do just go away. So there's an open question of whether operators are willing to do that.
Well, I think if there was some sort of essentially a longer timescale dampening function, instead of being dampened for an hour for flapping, being dampened for a period of time, or not accepted or delaying the propagation of that route.
Sure, what's that period of time then? It's got to be more than an hour, because most...
One day. I mean,
a day?
in my random thinkings, exactly a day is what
okay.
is the time scale I was thinking of. That way, you would delay how long it would take for things to, essentially, the brokenness to propagate across the network.
Yep. And you're clearly interested in a day. If other people are pretty much willing to do a day, then a huge number of problems just go away. But if people, due to customer pressure or personal taste, feel that accepting a new announcement, rejecting a new announcement for a day is too long, then we have more challenging issues.
Yeah, I think something that we've seen from our side and stuff that it was originally Internet MCI stuff, when they were building all their customer prefix lists off of their routing registry, those were normally pushed out once a day, and people would make special requests if there was something else. And something that we tell our customers on our webpage about our routing registry is make sure you plan your changes in advance. Obviously, for new customers, that might be a little bit more difficult, but there's that. And I'm also wondering how many people have spent time working with your vendors on ensuring that you can do the, telling them that you're actually interested in this for the stability of the global internet. And if SBC could answer on registering their routes.
What was the question?
Do you register all your routes?
I believe so. Yeah. I don't know. I'm not in operations, so. I know it should be policy. I don't know if there's something.
We're a little short on time, so let's just...
Everyone else, please do it as well.
Yeah. So,
Hi, Donnie Royceman, Sony Online. One quick question was, you showed the CPU load and the impact of load time. Did you measure the impact of just general churn?
That was one thing that we kind of talked about in the beginning, but we kind of held it back because once you start looking at going in detail like that, like actual churn, then the question is, well, if this is going to be some big internet peering core router, it's probably got private cross connects to every individual peer. And in that case, on certain platforms, let's say Cisco, you have input like hold queues, and then you need to have like a separate interface and for every individual peer. And we kind of kept it away and didn't go into actual churn. I mean, you could go into much more detail, so it was kind of very simple testing, but no, so churn, convergence, no, we didn't.
Okay, and then just another quick thing. At Sony Online, we're smaller enterprise, but we actually do very strict filtering of all our peers. What we do is we seed a prefix list with the routing registry, and on a daily basis we have a cron job that compares received routes to the prefix list, and we actually generate a list of all of the violations, and we send them to the peers, and folks like SBC did a great job of responding and registering almost all of the routes that were what we consider violations. And routes that they can't register for whatever reason because they might be customers, well, if we hear back from somebody in the peering group, yeah, those are valid, please accept them, we actually maintain our own exceptions list on a per AS basis, and that allows us to keep a really clean routing table for our peers. So, thanks.
Mike Patton, I'm a consultant. I had an interesting thought on part of your thing. Your model where you were talking about how many routes got through and got accepted and so on, you were talking about doing this with the rest of the network the same, and you were implementing this algorithm. I noticed in part of the algorithm, since you're basing it on what the other ISPs you peer with are accepting, if all of your peers were also doing the same algorithm, you have a chicken and egg problem again, and it's just an area to think further about.
Yeah, sorry, in the Kantian transcendental idealism sense, this is non-universalizable.
Yeah,
so,
okay.
But it is an opportunity for people.
But there probably are variants that might be.
Yes, but not all good things to do are universalizable. Stealing candy, for example.
Randy Bush, IIJ. As Jeff said, some of us are stuck in history and too old to move forward. And Vince, who just walked out, was going to queue up at the mic, but said, "Oh, okay, you'll talk about history." I'm very much a supporter of filtering, as many people here know, and first spoke of using the IRR and pushing this in '96. But historically, we have found that there's a reason that BGP is considered to converge too slowly, and that we've had a number of social experiments where significant providers, MCI was mentioned a few minutes ago, the more classic one was ANS, who was updating infrequently, caused great pain to people on the network. And my guess, I really don't know, is the public today expects even faster, and so I think the time domain is going to be very difficult here. I support the effort. I'm a filter Nazi, but I think the time domain is tough, and that's life in the big city.
Rüdiger Volk, Deutsche Telekom. In some parts of the talk, you were referring to trusted IRR repositories. Do you trust any that doesn't do RPSS? And how? And actually, which of the registries do RPSS?
Yes, I'm trying not to touch that with a 3-meter pole. We specifically referred to IRRs as trusted by that provider, with that trust being limited. I think that's an open and interesting question, and I encourage you to take it up with your IRR operators.
Well, my IRR is fine.
Great, then trust that one and don't trust any other.
And in Europe, actually, it is actually doable to tell our customers that, well, okay, we'll not accept any route that's not registered then. But, well, okay, if you're putting yourself into the shoes of a provider, what registry or what type of registry with what limitations would you trust?
So the number of registries out there, as Jim mentioned, is quite large.
Yes, and that's a problem.
Well, it's a problem if you need to have one registry. It's not clear to me. I'm sort of agnostic on that issue. I'm sympathetic to that perspective. It's not clear to me that having an entire region or the entire world in a single registry that's well run is necessary for the success of routing registries. It would certainly be one way to do things. It's also true that several large providers who are here maintain their own registries for their own customer information, and those registries are more useful for building prefix filter lists for the customers of those providers than is, the other countrywide registries that aren't right. Let's just put it that way. So it's an interesting set of questions.
Are you very quick, because we're almost out of time?
Okay. Larry Blunt from Merit. We run RADB, and we mirror quite a few IRRs, and we realize things are kind of a mess right now. And I just want to put a plug in for a mailing list we created a little while ago called IRC at Merit.edu for IRR coordination. So if you want to try to work through these issues together, I think that would be a good idea.
Are you going to support RPSS?
We'd like to, but I mean, it's not entirely within our hands.
Yes, I'm aware that your software manual says we don't support it. And, well, okay, there obviously is another factor that's important there, that you need the authoritative data for the numbers.
Right. Well, the model sort of starts at IANA, and so I think, I don't know how involved they're willing to be, but that's where it starts.